Okay, so factoring is rewriting something as a product. So that's really when you're asked to factor, what they're asking you to do is to rewrite it as a product. So it's always important to know what you're actually being asked to do, right? And we've done this already with numbers, of course. If you have the number 12, right, you can rewrite or think of 12 as a product. It could be 3 times 4, or it could be 2 times 6. If you continue to factor, so you continue to write things in as small of pieces as possible, then you'll see that no matter how you start factoring, you're going to end up with the same factors in the end, right? And these are the prime factors, because you can't break those down any further. And one of the nice things about numbers is that there's only one prime factorization. So no matter how you factor it in the beginning, you're going to end up with the same factorization in the end. And for many situations, it's much nicer to think of 12 as 3 times 2 times 2. It's sort of like broken into its smallest chemical parts, right? So you know exactly what it's made of when you factor something. And so our job is to move past numbers and work with polynomials. So we're going to do the same thing when we factor polynomials. And there's a lot of different strategies for factoring polynomials. And so part of your challenge will be to kind of identify the right polynomial that we have and then use the right strategy to factor it. For any polynomial, you can always factor out the greatest common factor, or the GCF, since we like abbreviations, right? So when we look at a polynomial like 8x cubed minus 6x squared plus 12x, right? When we look at polynomials like this, we are thinking about that polynomial in terms of its terms, right? There's those 3 terms or 3 pieces. And for the greatest common factor, we're trying to find a factor or a piece of each of these terms that's common, and we want it to be the greatest, so the biggest that we can pull out of each of these. So it's nice to just start with the coefficients. Remember, the coefficients are the numerical part in the front. So when I look at 8, 6, and 12, the largest number that's common to all 3 of those is 2, right? 4 goes into 8 and 4 goes into 12, so that's a factor of 8 and 12, but 4 doesn't go into 6. So I know that my GCF is going to be a 2. And then I look again at the next variable, which is just an x here, right? And I see an x squared, and an x cubed. So all 3 of those terms have at least an x, but no more, right? There's no x squared here. So this is my GCF. And I can factor or rewrite this trinomial as a product using that GCF. So if I'm going to, remember, if I write it out front, that means it's going to get multiplied by each of those terms. And I'd like, after I multiply it back together, to be the same as what I started with, right? So in order to get the 8x cubed, if I'm going to multiply something by 2x, that has to be a 4 and an x squared. One of the nice things about factoring is that you should be automatically checking your work, right? So as I am writing these in here, I am multiplying these together and verifying that it really does give me exactly what I started with. So then I know that I've got the correct answer, right? And I just move through each term in that same way. So 6x squared, that has to have been a -3 to give me the -6, and an x, and then finally 6, right? 2x times 6. So the GCF is the first thing that you should try and attempt whenever you are being asked to factor. And you can do it to any polynomial that we're going to run across. Not all of them have a GCF, but we can look for that in all of those. Okay. So this is my factored form. Do be careful. Sometimes the online homework will just ask you for the GCF. The GCF is 2x, but the factored form is the whole polynomial, right? What it would multiply back to give me whatever I started with. All right, so any questions on that? Okay. So the way we organize the rest of our strategy is we look at the number of terms. So after we do the GCF, or if there's no GCF and we want to continue to break the polynomial down, we have different strategies based on the number of terms. So if there's 4 terms, we're going to use a strategy called grouping. So here's the example or an example of that. Let's try 5x cubed minus 10x squared plus 4x minus 8. So again, make sure when you start this, you're counting the terms. That's how we always want to organize polynomials, and it's especially important with factoring. So we can see the 4 terms here. You would start by looking for a GCF, but you quickly notice that there is nothing common to all 4 of the terms, right? You have some parts that are common to other parts, but nothing common to all 4 of the terms, so we can't continue with that. What we can do, though, is group. Okay, so this is what we can do with 4 terms. We can group it, and within these first 2 terms, we see that there are some things that are common, right? There's both a 5 here and an x squared that's common to both of these 2 terms. So I can pull out a 5x squared, and that's going to leave behind an x minus 2. Right, and again, I am mentally checking that by distributing that back through and verifying it gives me what I started with. The same thing happens with these last 2 terms, right? There's a 4 in both of those, so I can pull out a 4. Now, what's important here is that we have not actually factored the polynomial, and it's because of this plus, right? As this is written, this is one product plus another product. So it's not written as a product overall. It's still 2 parts that are added together. But what's magical, right, about this grouping is that we end up with a common factor in both of these 2 pieces. So again, our perspective here has to change a little bit. The terms are here, and within these terms, each of those terms has an x minus 2 factor. So I can sort of start fresh and say they both have an x minus 2, so let's pull that common factor of x minus 2 out, and what's left behind is a 5x squared plus 4. Notice if I took that, it's a binomial, right? 2 terms, but that's okay. It can still be treated as one thing. If I distributed that to both of these pieces, I'd get exactly what I started with here, which is exactly what I started with in the beginning. This is factored, right? This is one binomial times another binomial. This is a product of 2 things, and this is the answer I'm looking for. You can also verify this, if you don't believe me, by multiplying it out, right? And we would do that by FOILing. X times 5x squared is 5x cubed. I'll multiply these 2 next. That'll give me a minus 10x squared plus a 4x you can kind of see where this is going, right? And a -8. Notice that's exactly what I started with. So these two expressions are equal to one another, but one is factored, and that's our goal here. Do remember that grouping is a two-step process. A lot of times I will have students that sort of get to here and then don't finish the problem, right? You have to pull out this extra binomial piece in order to finish your factoring. This is the answer we're looking for. Questions about that grouping method? Any questions about that? The nice thing is that you know that you're going to try it because you've got 4 terms. So as soon as you count 4 terms, that's a giveaway that you should try this grouping method. It won't always work. There's lots of polynomials that are 4 terms that when you factor parts out, you don't end up with this. But for our examples, you'll find that they will work. You'll end up with a factored polynomial at the end if you work through it correctly. So look for the 4 terms and then use that grouping method. Okay. With factoring and sort of moving forward with factoring, you'll probably spend most of your time and energy factoring trinomials. Trinomials that look something like this, or 2x squared. Let's do minus 2x minus, what will work here? Let's make that minus 3x minus 5. So I'm thinking there, I'm trying to make sure that I get one that factors. So a lot of trinomials won't factor and break down, but we're trying to look for ones that will. Now, these are not 4 terms, so we can't use the methods we had before. We've got to use something different. And what we want to notice is, or remember, is that this kind of result comes when we multiply 2 binomials together. So if you remember from what we did before the midterm, if you're multiplying 2 of these binomials together, remember we use our FOIL method. So we already did this once already, right? X times x is x squared plus a 3x plus a 2x plus 6. And of course, what happens is that 2 and that 3 add together to give us a trinomial that looks very similar to both of these. So obviously this wasn't quite the right one, but we could imagine that if we change the numbers around that it might be able to equal this. And the way we want to change the numbers around is to notice what's happening with these pieces, right? The 2 and the 3 here, because they created the 2x and the 3x, those add together to give me this middle term. And the 2 and the 3 here multiplied together to give me the 6, which is this constant term at the end. So what I'm looking for are 2 numbers that multiply to give me 8 and add together to give me 6. And you may have already figured out what those numbers are, but if you haven't, a nice little strategy is just to write down what numbers could multiply to give me 8, right? 1 and 8 is one option. That doesn't work because that's not going to add up to 6. But you could also get 8 from 2 times 4. 2 times 4, 2 and 4 would add up to 6. So that makes me, I think I might have found it, x plus 4 times x plus 2. And just like before, we like to check our work. X times X is going to give me the X squared. I get a 4X and a 2X. And just as we hoped, those are going to add up to that 6X I was looking for. And the 2 and the 4 are going to give me the 8. As the numbers get bigger, this gets a little harder, right? It's harder sometimes to see how the parts fit together. But the process is the same. Don't be afraid of trial and error here. There's nothing wrong with trying something and then figuring out, oh, it didn't quite work and give me what I wanted, so I'm going to go back and adjust and change things around. If you don't see the pattern right away, use this strategy to try and figure out what your options are, and that can give you a clue as to what might work. Let's try another one that's maybe a little harder. X squared. Let's try. Let's do X squared minus 2X minus 24. And, with all of these, our goal or challenge will be to factor. So first things first, it's a trinomial, 3 terms. So we know we're looking for this, right? The right parts that are going to FOIL together to give me this X squared minus 2X minus 24. And these are nice because the only way I can get X squared is with X and X. So in some sense, you're kind of almost halfway there, although that's very much the easiest half. So now I need a pair that gives me minus 24 and adds up to minus 2X. So I know one has to be positive and one has to be negative. My options for 24 are 1 and 24. See, 24 is a harder number, right? Because there's a lot more options there. 2 and 12, 3 and 8, 4 and 6. So remember, if one of these is positive and one of these is negative and they add up to minus 2, you should be able to think about which of those pairs is going to work. That one, hopefully, if we can get the parts right. So what if I try plus 6 and minus 4? Well, then when I FOIL this out, I get my X squared plus 6X minus 4X minus 24. I'm very close, but not quite, right? I got plus 2X and I should have gotten minus 2X. That's easy to fix, right? So I'm just going to go and I'm going to switch those around. So again, that's no problem, right? You made an attempt, it was close, but we adjusted it, right, to make it work. Questions so far? Some of you may have learned some kind of different strategies or different ways of thinking about it in the past. That is totally fine. If you have another way of thinking or working with these that works for you, go ahead and use that method. There's very little that's important about how we're doing this. We really just want a method that works for us, that allows us to break these trinomials down. So there are different ways of thinking about them. I find this to be effective as you move forward. If you can factor things pretty quickly like this, you'll get good at checking your work very quickly, but there are plenty of people who are great at factoring who use some kind of different strategies too. Okay, so let's go back to this other original problem. And you'll notice it's slightly different than the last couple that we did. The difference, of course, is this 2 in front. All the others had just an X squared in front. On one hand, it's not too hard because If I want to get a 2x squared, well, that just means one of these has to be 2x and one of these has to be x. That's not a big deal. But it does change how we FOIL, because remember, what is in this spot here is now going to get multiplied by 2x instead of just x. Over here, it didn't matter whether I put the 4 in this spot or the 4 in this spot. I'm going to end up with the same thing in the end. But here, it's going to matter what goes here, because that's the part that's going to get multiplied by 2. So sometimes people get fooled because they say, well, all right, minus 5, it can only be 1 and 5, and there's no way those can add up to 3. So this can't factor. Say not so fast, because it's no longer just, the 2x and the 3x. Now we've got this extra 2 that we have to incorporate into the mix. So it's even a little bit more of trial and error, a little bit harder to figure out how it works. The good thing is you don't have very many options to try, right? It's got to be either 1 and 5 or 5. So if I put a 1 here and a 5 here, well, I can see what happens. 2x times 5 is going to give me 10x, and that's just going to be a 1x. And no matter whether I add or subtract those, I'm never going to get to 3, right? So that doesn't work. So let's switch them around. So now what happens is I get a 5x and I get a 2x. And there, if we get the signs to work out, I could turn that into a minus 3. Turns out I want a minus 5x. So I'll put a minus 5 there and a plus 1 there. And then I check it. You don't have to write everything out to check it all the time. You can just think sometimes 1 times minus 5. That works. I saw that the middle terms are going to give me that. And the x times the 2x gives me that. So notice here I'm using even more of a trial and error method to get my result. Right? I wasn't quite sure how it all fit together, so I tried something, didn't work. I switched things around and tried something different. That's a little different for us. That's not how we normally do math. It's trial and error. We normally, every step is moving us closer to the answer. Here with factoring, sometimes we take a step and then back, another step and back, and eventually we get to that answer. This form here, we call this form ax squared plus bx plus c. So, and the focus there is on that a in front. That coefficient in front really changes how this polynomial factors. Let's try another example. Let's try 3x squared plus 12x plus 9. So I don't know because I can't see you at home, right? But hopefully some of you are thinking and starting about how to factor this. It's not a bad approach if you thought that this would be two binomials kind of like this one, right? It seems like it's very similar to the one we just did. However, that's actually not the right approach here. We want to make sure to look for the GCF first. So this version is actually kind of a harder version because this 3 is in front, but you can notice that each of these 3 terms has a 3 in it. So it turns out we can pull that 3 out. Again, we check by distributing. This trinomial here is actually like this previous version. right? There's a 3, but that 3 is not part of just the x squared. This 3 is a GCF. It's in front of the whole trinomial. So what I can do is I can just factor this x squared plus 4x plus c just like I would have over here. And this one's actually a kind of nice one to factor. It's just x plus 3, x plus 1. This is a very different problem than this one. I mean, the numbers don't look very different than the last one. Do you see what the difference is? There is no GCF here. I can't pull a 3 out of the 11. So I'm not able to rewrite it like I could the last one. This one is actually like this form, ax squared plus bx plus c. I got to incorporate that 3 into my factoring. One and 6, 2 and 3. As you get a little better at factoring, you'll be able to kind of pick the right answer more quickly. But sometimes in the beginning, it's hard for you to see where it is, and you'll just have to try things and see that it works. I can tell you right away that putting a 6 over here isn't going to work because that's going to make this 18, right? 3x times 6 is going to be 18. That's already way too big. So maybe a 6 here and a 1 here. That would give me 6x and 3x. It's only 9x. That's not what I wanted. So that didn't work. So that's fine. I'm not worried about that. I just know that it couldn't have been 1 and 6. I just keep working. I put a 3 here and a 2 here. 3x and 6x. Remember, I'm multiplying it by 3 over here. 3x and 6x. No, that's only 9x again. That's not what I wanted. That's fine. So put a 2 there and a 3 there. Right? It's a good reason to do your work in pencil. So you have to be an optimist here, right? I have to say, I hope that I'll find something. I don't know, but I'm hopeful. 3 times 3 is 9x, and 2x, that's 11x. We got it. We're feeling good. We're ready to move on. Well, I need to make sure this one was nice because they were all pluses. Some of you will see some problems more quickly than others. That's great. But what matters is that we can get to that right answer. All of you will sometimes get stuck on ones and you'll have to fall back on just trying some options. It is true, as I said before, that not every polynomial factors. And that's true for trinomials as well. X squared plus 3x plus 5. It seems like an ordinary enough trinomial, just like the rest of the ones we've looked at. But no matter how you put in the options for 5, you can't get them to add up to 3x. And numbers that don't factor anymore, we call prime. So you will run into some prime, some prime polynomials, but don't jump to that. You got to make sure you've really tried all the possibilities before you can determine that it's prime. Questions? Any questions? You're all very quiet after our spring break. That's okay, but does anyone want to see any other examples of these before we move on? Okay. Like I said in the beginning, this factoring of trinomials is really an important skill. And once you get it, you've got it and you'll be good at them. But until then, it can be a little bit of a struggle. So make sure you're investing the time to do well in these sections, because it's really going to pay off as we move through the rest of this course and future courses. Some topics we only see like a little bit, you know, and maybe they show up in the test or maybe they don't. This is one that we're going to see, you know, all in this section. We'll use it in our next section. We'll use it all the way through the rest of the course. So don't let this one slip through the cracks. Okay, so we've covered the GCF. We've covered 4 terms, which was grouping, and we've covered 3 terms, which is just trinomial strategy, and now we're down to the 2 terms, right, which are binomials. You may, if you've worked with factoring before, you may have seen a lot of those previously, and you've probably seen a little bit of work with binomials too. The general form is that when you have the difference of 2 squares, you can factor that as a plus b and a minus b. So for example, maybe I have x squared minus 4. Right, notice that's a binomial, 2 terms. And this formula says that that should factor as x plus 2 times x minus 2. And when you check your work, you can see why that happens, because the foiling, x times x is the x squared, plus 2 and minus 2 is the minus 4. And the middle terms are both the same, but opposites, right? So we get a plus 2x and a minus 2x, and so those are going to cancel. And we get exactly what we were looking for. So that's really nice. The difference of squares is nice because it's like a formula. You can move directly to the answer. You don't have this like, I got to try this one or try this one thing that you have with the trinomials. But there are other ways that binomials factor too, and you may or may not have seen these other strategies. So the difference of cubes, and this would be a good formula to write down on your note sheet for the final. It's a little hard to remember. A minus b times a squared plus ab plus b squared. And I'll write down the sum of cubes in the same way. A plus b, a squared minus ab plus b squared. This top one, normally people don't have to write down because you'll do enough of these, it'll be kind of second nature, this factoring. But these cube ones, you can see they're very similar to each other and there's a lot more pieces. So it's much harder to remember those successfully. So let's see some examples of these. Let's try x cubed minus 16x. So I'm pausing so that you take a look or think about how to factor that. You should notice that there's 2 terms. So you should be thinking one of these 3 strategies. But you should also notice, if we were in class, someone would say it, but it's harder online, right? You should also notice that there's a GCF here, right? There's an X. We always want to pull that GCF out first. If you don't pull that GCF out, it doesn't actually really fit any of the forms. But once you pull the x out, you can see this is x squared minus 16. This is still that difference of squares right here from above. So that's going to be this x, and then it's going to be x plus 4 and x minus 4. Okay. How about 8 plus x cubed? So 2 terms, which means we're looking into this type, no GCF. If it doesn't fit, then we don't have a way of factoring it. So it has to be one of these 3 types, or else it's going to be prime. It's got a plus in the middle, so our only chance is this one. And I know that 8 is really 2 cubed. Right? So this does fit this pattern. And what's nice is once you see that, you don't have to do a lot of thinking. You just got to take and put the right values in for A and B. So for our example, A is going to be 2. So this is going to look like 2 plus x, right? B, the B is the x here. So 2 plus x, and then 2 squared, which is 4, minus AB, which is 2x, plus B squared, which is our x squared. This little trinomial looks like it might factor, but it won't factor. This form always leads you with something that doesn't break down. Okay. So the cubes sometimes give students trouble, but I always feel like they don't have to, because you have the formulas here. You just have to fit the pieces into the formula. But you do have to recognize which type of form you're looking for. Also, just as a little side note, x squared plus 4 is prime. The sum of 2 squares is always a prime number. You just can't factor that. If you don't believe me, you should try it, and you'll just see that, like, you can't get the middle terms to cancel and the last term to be positive. The only way for those middle terms to cancel, like what they did here, is for one to be positive and one to be negative, which forces that constant term to be a negative. Okay. Questions about that? Hopefully that means I'm doing a good job of explaining it. I'll assume that that's the case.
Yeah, that's the case. But one question: can you do a harder one?
Yeah, for the cubes.
Yeah, for the cubes.
Yeah, definitely. You're right. Some of these are kind of, this is like the easiest possible one right here. The things that make it harder, like if I'm going to write a harder question for the test, I would put in a GCF, which if you see it and pull it out, it's not that hard to do, but sometimes students don't notice that. So you would look for the GCF first, and then I could sort of combine some numbers together. I wouldn't use really big numbers. So like 5 cubed is 125. I wouldn't use anything bigger than that. I keep the numbers pretty small. But let's try one like 54 minus 16x cubed. I mean, I certainly could make them harder, but I'm not that kind of guy. We want to just focus on the basics here. It is true with factoring, like we learn some factoring. There are lots of complicated strategies. There's lots of strategies that I haven't seen or don't know about. And at a certain point, they're not all that useful anymore. So it's the same idea with cubes. You know, it is a strategy, it works, but we're not going to deal with super complicated ones. But this one is more complicated, right? It's two terms, kind of a lot going on here. My first thing always is to look, are these squares? Because that's kind of the easiest one. And these are not perfect squares, right? 16 is a perfect square, but x cubed is not. So it's not a perfect square, right? I need this whole thing to be a perfect square and this to be a perfect square. So the next thing I would look at here is I'd say, is there a GCF? I always want to pull out the GCF. It's going to make your life easier, my life easier, everyone will be happier, right? And so we do see these are both divisible by 2. Right, not hard to do, but once you do it, it really does clear up a little bit of what the problem is. So now 27, I know, and you guys will recognize that's 3 cubed, 3 times 3 times 3, and 8 is 2 times 2 times 2. So this right now is well on its way towards this difference of cubes. You don't have to do this step because you could just know it, but it's not a bad idea to just write down that the A is really 3 and the B is really 2x in this case, right? So now that fits this form. Everywhere I see an A, I'm going to put 3. Everywhere I see a B, I'm going to put 2x. 3 squared is 9 minus 3 times 2x. Right, that's this. Sorry, not minus. Plus, right? Good thing I have my formula to look at, right? And then b squared, that b is 2x, so that's going to be 2x squared. That's 2. 3 minus 2x. 9 plus 6x plus 4x squared. And you don't have to worry about simplifying or going any further there. That's what we're looking for. Does that help or?
Yeah, that helps.
Okay. I think, you know, once you see how the formula works, they're kind of all the same really, right? I mean, I can change the numbers around a little, but it's still just plugging those pieces into the formula. So it's not a lot of kind of magic here, but again, it's often kind of new for people who have even seen factoring before. So look for that one with the 2 terms. Okay. Any other questions or any other examples you guys would like to see? Okay. So I just have kind of one more topic to cover here. The first half of your homework is just all those different factoring. I think the first 3 assignments are just different kinds of factoring, maybe even the first 4 assignments. But then we move into solving. And so I want to make clear right from the beginning here that there's a big difference between factoring and solving. Factoring is just rewriting it. It's taking, so if I say factor x squared, you know, whatever, 10x plus 21, that's not an equation. It doesn't have any solutions because it's not an equation. All I'm able to do and all I'm asked to do is rewrite this and it turns out that's going to be 7 and 3. So I'm done. Okay. Solving is finding solutions or finding values that make the equation true. So the answer to a solving question is going to be a number or a couple numbers. So, you know, if you solve something like this, well, we know how to do that one already, right? We subtract a 3 from both sides and we divide by 2. And our answer or our solution there is 4. So it's a very different thing we're being asked to do. But when we have certain types of equations, well, let me give you this. Let me work our way there. Yeah, let's try this. So here's an equation where I have two pieces that are multiplied together and I say it equals 0. Now, there's a special property called the zero factor property, and it sounds fancy, but you guys can figure that out without that. If I'm going to multiply two things together and get 0, the only way that can happen is if one of the things was actually 0 to start with, right? If they're both not 0, when I multiply them together, I'll never get 0. So the only way I can get 0 here is if x plus 2 was 0. And I can figure out very quickly that that only happens if x is minus 2. So if x is minus 2, that makes this piece 0, and who cares what this piece is, because 0 times anything is 0. So that's a solution. And the same strategy can work here, right? X minus 3 equals 0. That means x has to equal 3. Again, if you go back and check, you can see that works. This is going to be 5, but it's going to be multiplied by 0. So what I get out of that equation are I get these two solutions. Okay. Now, what if I gave you an equation like this? This is called a quadratic equation. It's a new class of equations. This one was called linear. It just had one answer. This is a quadratic equation. We can't get the x alone like we did with that linear equation, but we could, hopefully you see this, maybe write this equation in this form, right? And from here I could find the answers. So notice in order to do that, I have to factor. But the factoring is just a tool or a step to help me find the answers. It's not the end of the story. So this is actually the same one I did over here, right? So x plus 7 times x plus 3 equals 0. These are the same equations because this trinomial is the same as this factored form. But this factored form is really nice because now that it's factored, it's multiplied together. And now I can figure out how this could possibly equal 0. Up here, I can't because they're added together, and addition doesn't work that way, right? You could have, if one thing's 5, the other thing could be minus 5, and you got this 21 in there. It's really hard to know how it all fits together. But the factored form, there aren't a lot of options here. X plus 7 has to equal 0. So x equals minus 7, or x plus 3 equals 0. So x equals minus 3. These are my answers. This is what I want. I need to factor to get there, but I can't just stop here. That's not telling me what the answers are. I need to figure out what the values are. In the same way, this problem, I can't get solutions because there's no equation. This isn't equal to 0. It's not equal to anything. There's no true or false because it's not even an equation. So I'm making a point of that because I see students mess that up, and I don't want you guys to be those students, right? I want you guys to know, because it's not hard. It just means it's just something you have to pay attention to, right? And know that you're looking for it. So if you're asked to factor, your answer is going to look like this. If you're asked to solve, your answer is going to look like this. They're going to be numbers. And if you plug those numbers in, you're going to find out they make the equation true. Right? That's the sort of point of these solutions. And I don't know, maybe that's worth doing one of these. I don't know if you believe me or not, right? It's like, does that really work? It's kind of a new strategy. If I put in -7, that should equal 0. -7 squared is 49, -70 plus 21. 21 and 49, it is 70. That works, right? And you'll see -3 also works. So this technique is what we're going to use when you're solving these equations. But in order to solve, you got to be able to factor. So that make sure you're spending the time on figuring out factoring the first part of this week, and then you can work towards solving equations in the second part of this week. And of course, keep me up to date with any questions that you run into. Okay.